Jamboard. Well, I guess we'll go from basics then. So to be really rudimentary, would you know how to draw the graph of, say, y equals 2x minus 3?
Oh yeah, I know how to draw like those ones.
Okay, so can you give me a rough sketch of that one?
Yeah.
Do you know how to draw a straight line on this?
I think so.
If you're using a computer,
Yeah.
if you hold shift and then draw, you'll draw a straight line.
All right. Oh yeah, sweet. All right.
So I drew a set of axes for you, x and y. So I want you to draw it and show me roughly where it crosses the y-axis and where it crosses the x-axis.
Oh my god.
Nice. And can you also determine where it crosses the x-axis?
Yeah. Is that right?
Nice. How did you work it out?
For x-axis, you make y equal to 0, don't you?
Yep, that's it. Good stuff. Okay. On the second slide, then let's move on to this kind of graph. There will be three things I'll ask. So y equals x squared plus 7x plus 12. Do you know what the graph of this would look like roughly?
Yeah, I think so. X.
Are you just thinking about it?
Yeah, I'm just getting the.
Awesome. Cool. One thing, I mean, I'm guessing you got this from one of the pre-drawn shapes.
Yeah.
That's cool. Um, where is it crossing the y-axis?
I couldn't really like. I'll try to extend this actually. Just pretend that's like proper.
Yeah, that's fine. A simple sketch, it doesn't have to be like the Mona Lisa or anything. It can be
Yeah.
that's fine.
I think that's the y-axis. I'm not really sure about the turning point.
Okay. Do you know physically what the turning point looks like on the graph?
Oh yeah, it's this bit here. The uh,
Mm-hmm.
that bit there.
Mm-hmm. Cool. So first of all, let's just let me do this. Just to make it look a bit like a parabola at least. Okay, so it looks a bit more like a parabola. Now, to work out the turning point, you need to, well, there are two ways you can do it actually. You can use completing the square or you can use differentiation.
Yeah.
What method would you prefer?
Uh, Probably differentiation.
Okay, so we have that y equals x squared plus 7x.
Is it 2x plus 7?
Pardon?
Is it 2x plus 7?
For dy dx, yes, that's right.
Yeah.
That's right. So you've got dy dx equals 2x plus 7. Do you know what we do from here?
Would you find out what x is to equal 0?
Yep.
All right, so minus,
How do you say it?
would it be minus 3.5?
Yep, nice. So x equals minus 7 over 2 or minus 3.5. So we know that the x coordinate of the turning point is minus 3.5 or minus 7 over 2. And the y coordinate, how would you work out the y coordinate?
Do you put that back into the equation?
Which
Like the
equation?
first? Do you
That's
put
it.
that back into the first equation?
That's it. Perfect.
All right. Uh,
Whilst you're doing that, I'm just going to make a quick note for how you worked out the the x-intercept. So the y-intercept is 12. That's subbing in x equals 0. X-intercept, you let 0 equal x squared plus 7x plus 12. So this is 4. Work out the x-intercept. Factorizing. Then x equals minus 4 or x equals minus 3. So we got minus 4 minus 3 for the x-intercepts. And the y-intercept after subbing in x equals 0. Yeah, x equals 0. And then boom. No.
Is it minus? I got minus 0.25.
Minus 0.25. Okay, let's just double check. So we've got y equals. I guess it's just checking that we've got it all good on the calculator. So plus 7 lots of minus 7 over 2 plus 12. Oh my gosh. Did you put it in the calculator?
Yeah,
Okay, cool. And you got what?
I got minus 0.25.
Minus 0.25. So minus, so that becomes 49 over 4 minus 49 over 2, which gives me minus 49 over 4. And then minus 49 over 4. 12 is 48 over 4. So minus 49 over 4. 1 over 4. Okay, cool. Yep, yep, yep. That works. Minus 0.25. Nice. So I guess we can add that to the other coordinate, right?
What?
As you typed.
Oh yeah, pretty good then. But yeah.
Yep. And then just always make sure that with coordinates we have these parentheses, these brackets.
Oh yeah.
Let's kind of added it. There we go.
Sweet.
So yeah, they're the things that we need to know for a quadratic graph. So okay. What about a graph like this? Uh, there we go. So on slide 3, can you sketch that graph? Again, thinking about the main aspects. So whenever you're drawing sketches of graphs, you kind of want to ask yourself, if it's at all possible, um, x-intercept, or where it crosses the x-axis, y-intercept, um, any turning points maybe,
Yeah.
or asymptotes if they apply. In this case, it doesn't apply, but there are some graphs where, these are some good things to think about to give you an overall figure of the shape. So I'll draw a set of axes for you, and then you can go.
Sweet.
Nice. So there you're differentiating to get 4x minus 7.
Yeah.
Okay, so you make it equal to 0 and then you solve for x to be 1.75. Cool.
Mhm.
Then to get the y coordinate, yep, you've substituted it into the original equation.
Yeah.
Oh, so nice. Sweet. Okay, the next type of graph um, is the x cubed type graph.
All right. X cubed. I'm not sure how I'm going to draw this, but I can try.
Mm-hmm.
Not sure how I'm going to draw this.
Mm-hmm.
I can try.
So x times x minus 1 times x plus 1. So I've given it to you in factorized form already, which hopefully should be useful, but you may wish to use other forms. So first question is, well, is the y-intercept,
All right.
x-intercepts, um, any turning points, and asymptotes. With this, oh, I see what you mean by you're not sure how you're going to draw it. Don't worry too much about drawing like it perfectly. You can just
All
draw
right.
it with your pen, like your trackpad or whatever you're using, and it can be rough.
All right.
So yeah, if anything, just you can get rid of the shapes because the shapes actually might make it a bit more confusing.
All right.
Honestly, a rough sketch with your
Sweet.
is better. Oops. Yeah, but the first questions you can ask yourself, sorry, is just what are the y-intercept, x-intercept turning points and asymptotes, if at all any.
Yeah. Oh, let's pretend that's like proper. I know the x-intercepts, they aren't too bad, but I'm not sure what I'd do for the y.
For y-intercept,
Yeah.
well, I guess the question is where does it cross the y-axis?
Oh, yeah.
I mean, okay, let me just change the shape of the graph ever so slightly. I know you tried your best with the trackpad,
Yeah.
but let's just tighten that up just a little bit. Oh shoot, no, like that. Wait, are you able to undo what you did, like Control Z?
Oh, yeah, pretty. Oh, I think so.
And again, like you might have to press it a few times.
Oh, sorry.
Yeah,
There you go.
cool. The fact that you drew it and you kind of made it cross at the correct places is good. My graph isn't perfect either, but it just makes it a bit clearer.
Yeah, that's better than mine.
But I've got equipment to use it, so
Yeah.
yeah, cool. So yeah, so what is the y-intercept?
Y-intercept, would it be? Oh, 0 as well.
Yes. So you know how you told me for x-intercept you make y equal to 0.
Yeah.
For the x-intercept, sorry, for the y-intercept, you make x equal to 0.
I see.
And then the other question is, what are the coordinates of the turning point?
Pun?
The coordinates of the turning points?
Turning points. Would I have to differentiate again and then
Indeed. So how are we going to differentiate this function?
all right. Would you? You have to expand it out first.
Indeed. You can do that on
So
paper, by the way. You don't have to do that on the Jamboard.
yeah. All right. Is it just x cubed?
I'd say try and do it, quote, the long way, unquote.
All right. Yeah.
Multiply the brackets, then multiply the result by x. Though I can see kind of why you might have guessed x cubed.
Oh, x cubed minus 1x.
Yeah, x cubed minus 1x, x cubed minus x. So we see that with this first expansion, we have x times minus 1 times x plus 1. That's the difference of two squares. So x squared minus 1 squared, which is 1.
Yeah.
X cubed minus x. And then therefore, dy dx equals
dy dx equals 2x. Yeah, 2x.
Equals what?
No, sorry, 3x squared.
Just that?
Yeah, 3x squared, right?
No.
3x. Oh, 3x minus 1?
3x squared minus 1, yeah.
Oh, yeah. Would it be a third?
Would it be a what, sorry?
Minus a third?
Minus a third?
Yeah.
What have you done?
Made x. What? You have to find out what, like, y. No, you have to make y equal to 0, don't you?
Make
And then
what equal
find out
0?
what x is.
Not y, but dy dx.
Yeah, yeah.
So we say 3x squared minus 1 equals 0.
And then 1 equals 3x squared, and then you can't square root 1, can you?
Well, before doing any square roots or anything, we need to do something else.
Divide by 3.
Yep.
Alright, so it equals a third.
Mm-hmm.
And then square root of a third, is it?
Is that the only answer?
Yeah. Or it could be minus.
Yeah. So there are many ways in which we can write this, but I guess for the purpose of ease, we'll just leave it like this. Okay, so those are and note how it makes sense that they're going to have two answers because you've got two turning points in the graph. You've got one over here, and we've also got one over here.
Yeah.
So you've got x equals the square root of a third, and you've got x equals minus the square root of a third.
Yeah.
So based on that, what's the y coordinate going to be?
Would you put it back in to the equation?
Which equation?
The first one, yeah.
Yep. Okay.
Oh,
So I'll let you work that out.
all right. Equals square root of 3 over 9.
Say that one more time.
Square root of 3 over 9.
The square root of 3 over 9. For
Yeah.
what? The y coordinate?
Yeah.
Okay.
And then minus the square root of 3 over 9 as well, wouldn't it?
Did you get that from your calculator?
I got the first one, square root 3 over 9 from the calculator, yeah.
Okay. Just check with the other one.
Will do.
We always want to be sure.
Oh, no. 3 over 9. Take away. I got minus 2 root 3 over 9.
For the other one.
For, yeah. No, for the first one, because I forgot to take away the. Oh, it's so annoying and the fucking absurd stuff.
Yeah.
It's so like complicated.
Well, the calculator is there, right? It's there to help, but you've got to
Yeah,
be careful with it.
it's just like when I'm trying to read them out, it's really like weird. But I got -2 √3/9. Yeah,
For which one?
for the first one.
Okay.
And then the other one, I got the same, just without the minus.
What's that? Sorry.
The second one, I got 2 √3/9.
2 root 3. Okay, that makes more sense. Okay. Cool. That kind of makes sense because yeah, there's that kind of symmetry. So yeah, those are your turning points. Again, we can always write the format in a different way, but let's just keep it like this. Apologies for that noise.
Right.
Wait, I'm not even. This is square root of a third, comma 2 √3/9. And for the other one, cool. So yeah, the other one we got the square root of a third minus 2 √3/9. So yeah, they're the main aspects that we need to know. What about next slide? If we had to sketch.
Oh, sorry. Didn't realize on the next slide.
No problem. So again, I'd say before sketching this one, determine all the four things that we talk about. So x-intercept, y-intercept, turning points, and asymptotes, if any.
Yeah.
So again, determine those things before you draw the graph. So I'll let you have a chance to think about that.
All right, I think I've got like a fair idea.
Actually, what was
Is
that, Kieran? Definitely not.
it's touching the thingy, right?
How do you know?
Because it says squared.
Well, I'll let you give me more. So that is right, but I'll let you give me another reason that's probably a stronger reason as well. So after working out all those things, you'll be able to determine why.
What do you mean?
Yes, it will be touching, but I want you to also give me another reason why it will only be touching. But after you've worked out the x-intercept, y-intercept, and the turning points and the asymptotes, you'll be able to tell me this other reason, hopefully.
What's an asymptote?
We'll get to that when we draw our next type of graph.
All right.
How's it going?
Good, thank you.
What's that?
Good, thank you.
Cool.
Uh, I don't. It doesn't. Wait, it crosses the x-axis at 0. No, the y-axis at 0, 2.
Wait, it crosses the x-axis at.
The x-axis at what's it called? X-axis at 0, 2, and 2,
Okay.
and the y-axis at 0.
Okay. Nice. So you got repeated roots, and then what about the asymptote? No, the turning points.
I'll do that now.
Cool.
I got the x coordinates for the turning points.
What was that?
I got the x coordinates for the turning points.
Oh, did you? Right. Okay. So, how did you do it?
It was like you differentiate and then you got a quadratic, and then I did the quadratic.
So, how did you differentiate it, first of all?
It was x cubed minus 4x squared plus 4x.
Cool. So let's just expand that. So x times x squared minus 4x plus 4, x cubed minus 4x squared plus 4x. Okay. Then you differentiate it to
Differentiate to 3x squared minus 8x plus 4.
minus 8x. Yep.
And then for the quadratic, I got x equals 2 over 3. Or x equals 2.
So you end up getting x equals 2 over 3 or.
X equals 2.
Okay. So now that you've got that, where was one of the turning points again? It was at 2. So using that, could you give me another reason why it only touches the x-axis at 2 rather than go through it?
So you say again?
Could you give me another reason why it only touches the x-axis at 2 rather than going through it?
Because that's how the graph is. I don't know.
I mean, it is like that, but why? So the point is, the reason it's touching is because we know that's the turning point.
Yeah.
That's it. That's the other reason. So you can go, oh yeah, it's an x minus 2 squared graph, therefore it touches. But also the other reason is because it's a turning point at that point.
Yeah.
This coordinate is going to be 2/3. What's the y coordinate of that turning point?
Y coordinate is the turning point would be 0, wouldn't it?
What's that?
Turning point would be 0 on the 2.
The 2 what?
The x the x-axis 2.
The x-axis 2. I don't understand. Sorry, say that again.
the turning point. Oh, sorry. I thought you were talking about the turning point, like for the 2 x-axis equals 2.
Yeah, that one's 0. So what's your reasoning for that anyway? Whilst we're on that,
What do you mean?
like, why is it 0?
Because it only touches.
Yeah, so only touch, as in yeah, I suppose that's good enough. But I guess the other thing that I was looking for was because the x-intercept we know was 2, so
Yeah.
touching there on the x-intercept, y is equal to 0. So that's it. And then for the other one,
The other one. I'll do that now. Is 1 point. Oh no, it's 1.18.
is it exactly 1.18?
No, it's 1.185185185.
Ooh, that is a long decimal. Wow. Are we able to give like an exact answer or as a fraction, maybe?
32 over 27.
Oh, okay, that sounds a bit more. That sounds a bit more. Yeah. 32 over 27. Okay, we can accept that.
Can you send me like more questions on these?
Of course. I mean, to be honest, I made these questions up, but I will happily send you questions
Thank you.
that relate to sketching these kinds of graphs.
All right, thank you.
Nicely done. Well, I think we might see each other tomorrow.
Yeah.
Yeah, cool. I'll organize a time and I'll get back to you with a time.
Yeah.
Listen, but nicely done. Again, just reviewing, we've done drawing a straight line, we've done drawing a quadratic, 2 quadratics even, and we did drawing 2 cubics. Yeah, I'll give some more questions. I'll send it. How do you want me to send it? Via email?
Yeah, email will be good. Thank
Cool,
you.
I'll do that. And tomorrow we'll carry on the sketching of graphs. We'll sketch some different types of graphs.
All right, thank you.
Awesome. Well done again. Take care.
See you.
Right. Bye.
Bye.